Hello, welcome to our video about trigonometry word problems. More specifically, we're going to be discussing angle of elevation and depression. So, before we discuss these things, we should talk about the definition. So, both the angle of elevation and the angle of depression are measured from a horizontal. So, we have the angle of elevation is commonly measured from something typically below, and it's measured up. The angle of depression is measured from the horizontal going down. Now, the concept itself seems very simple, but when put into practice, it's very easy to mess up. So let's just do a couple word problems. Brian's kite is flying above a field at the end of a 65-meter string. If the angle of elevation to the kite measures 70 degrees, how high is the kite above Brian's head? So here's Brian. And he is flying a kite, and it has 65 meters of string. We'll go ahead and draw our kite. Now it says the angle of elevation. Now it's measured from the horizontal. This horizontal line is kind of imaginary. You could think of it as maybe being from the top of Brian's head or something like that. But this angle right here is 70. So you want to know how high above the kite is Brian's head. So that would be this measurement right here. We'll call it h for height. Because I could pick up this measurement h and stick it right here, and it would be the same. So now we have to decide if we have a sine, cosine, or tangent problem. Let's see, I have the opposite, and I have the hypotenuse, and my acronym SOHCAHTOA. I have the sine, so I'm going to say the sine of 70 is h over 65. And this is when I need to pop out my calculator. Again, if your calculator is in degree mode from last time, it should not have changed. Get h by itself, you should multiply by 65. So in your calculator, you are going to multiply 65 by the sine of 70. And you get 61.08. So I'll just say 61.08. And since this is a word problem, I have measurements. It would be 61.08 meters. Not too bad. Angle of elevation, start from the horizontal, rotate up. From an airplane at an altitude of 1,200 meters, an angle of depression to a building on the ground measures 28 degrees. Find the distance from the plane to the building. So here's my plane in the air. And there's a building over here, and we have the ground. Now, imagine there's an imaginary line connecting these two things. We know that the airplane is 1,200 meters in the air. And here's my right triangle. Now the angle of depression. A lot of times people want to say that this is the angle of depression because that's the angle inside your right triangle. That is incorrect. Your angle of depression has to measure from a horizontal down. So there's an imaginary horizontal line level with the airplane. That is 28 degrees, which conveniently, this imaginary horizontal line and the horizontal line that represents the ground, those would be parallel. So if this is 28, this would also end up being 28, which kind of works out nicely because they're alternate interior angles. Now, find the distance from the plane to the building. Technically, there are two different distances from the plane to the building. We have the horizontal distance, that's as if you were measuring on the ground, and then you have this measurement that represents the hypotenuse. This is kind of what we're actually finding, how far away they actually are if you were to try to go from like the plane to the building. So sometimes it'll ask for horizontal distance, other times it just asks for distance. A lot of times the context of the problem will tell you which thing you need to find. So let's think about this. We have an opposite side and we have a hypotenuse. So this is again a sine. So we have the sine of 28 equals 1200 over x. This is one of those times when I have to multiply to get rid of the fraction. And then divide by the sine of 28. And this is when I go to my calculator. Divided by the sine of 28. And I get 2,556.07. And this would be in meters as well. So if you would have put the 28 in the incorrect spot, you would have gotten a totally different answer for your length of your hypotenuse. A 14-foot ladder is used to scale a 13-foot wall. What angle of elevation must the ladder be situated in order for the ladder to reach the top? So I have a wall in a building that's 13 feet, and I have a ladder. Here's the ground. That's 14 feet. I want to know what angle must the ladder be situated to reach the top of the wall. So I want to know this theta. Remember, you can put whatever letter you want in there. A lot of times when we talk about angles, we use Greek letters. The popular one is theta. So looking here, looks like I have another sine. So I have the opposite and the hypotenuse, which is sine. So I have the sine of theta equals 13 over 14. This is when I need to go to my calculator and do the inverse sine. Remember, you can't divide by sine. That's not a thing. The opposite operation of sine is the inverse sine. Second sine this time of 13 divided by 13. And you get 68.21. So theta is 68.21 degrees. And that's all I have for you today. Feel free to work on your practice problems. Let me know if you have questions.